So last section we're going to look at is 9.2, and this is called polar coordinates in graphing. 9.2 part 2 gets into full graphs. In 9.2 part 1, we really only graph single dots, just coordinates. And I think for us that might be all we ever get to. All right. So up until now, we've used two different modes on the calculator. Does anyone remember the name of the mode we've been using all year before yesterday?
Function.
Function. And then yesterday we used parametric. Whether you use function or parametric, both of those two modes still operate on an XY axis. They still operate on a piece of graph paper that has a horizontal axis for X and a vertical axis for Y. Polar does not. Polar is it uses like a different kind of graph paper. Polar graph paper looks more like that. Okay, that's polar graph paper. So when you press polar on the calculator, this is the kind of grid that the calculator is using. When you press function or parametric, that's the kind of grid the calculator is using. Okay. So any question on that first? So this kind of grid is really good if you want to draw straight lines. Okay. Y equals mx plus b, very simple equation to use to draw straight lines. Drawing lines in this system, no, it's not simple. Okay, drawing lines is not what this system is designed for. It can be done, but that's not what you're supposed to use it for. Okay. So there are some curves that can be drawn in a much easier way using a polar coordinate system. What I'm going to do now is I'm going to draw a circle. And I'm going to draw it in every mode that we've learned about on the calculator. I'm going to do it as a function, which we already know. Do circles pass the vertical line test?
No.
No. So it doesn't even really pass the vertical line test. So the only way I can do it is kind of cheat and do the top half and the bottom half separate. It's the only way I can do it in a function system. So I'm going to do it as a function. Then I'm going to do it the way we learned yesterday in parametric. And then I'm going to do it in polar. And I'm going to show you the differences between all three. I want you, when we're done, to tell me which system you think is the simplest for drawing a circle. Let's start with function. Okay. So to type in the equation of a circle, we need to use this formula. That's the equation of a circle. So as a function, I need to solve that for y. So I have to minus the x squared, and then I have to take the square root of it. So it's not this, it's not awful, but there are a few steps to get y by itself, and that's what you have to type in if you want to draw a circle. Now I'm going to do a circle with a radius of 3. So I'm just going to let r be 3. So what's 3 squared?
9.
9. So let's draw our circle and just change that to a 9. So square root of 9 minus x squared and the negative of that. Because when you take a square root, you always get 2 answers. And that should give me a circle. It's going to be in 2 separate pieces. I kind of want to zoom in a little bit. It doesn't even do that good job connecting them because the sides of the circle start to get vertical. And we know when things start to get pretty vertical on the calculator, it has a little trouble connecting them. But that's as good as I can do for a circle with a radius of 3. And it actually looks like the gap on the right is bigger than the left. It has a lot of trouble. Okay, so there's my circle. Let's go like this. And here are the equations that generated it. Okay, and what mode was that again?
Function.
That was function. So truthfully, I can't even really draw a circle. I can kind of make one look like a circle, but it's not even a good circle. All right. So now let's go to parametric. Okay. In parametric, well, we just did a spiral. If I want to do a circle of a radius 3, I pretty much have the equation there. I just have to change one thing. What do I have to change to make that a radius of 3?
The T in front
The
of
T in front. And what would it be?
3.
3. And I wiped out the bottom one because I had changed it. 3 sine t. Okay, let's hit graph on that. There you go. The advantage there is I actually got a real circle. Okay. I didn't have to try to draw 2 separate pieces that kind of look like a circle. Okay, and what mode was that?
Parametric.
So that was parametric. Okay, so you get the real shape, and the equations, well, I don't know if they're more or less simple than what we had before, but they do use trig. So you have to understand sine and cosine to draw that circle. Right. Now, let's do it one more time. Let's hit mode, and let's go to polar. And I want to draw a circle with a radius of 3. And there we go.
That was great.
Yeah, so that's polar. And all that I typed in to do that
That's 3.
was that. Actually, I'll put it below it so it looks like everything else. And what mode was that?
Polar.
That was polar. So, looking at all 3 of those, right, the function, parametric, and polar, which one was the simplest to draw a circle? Yeah, polar was definitely the simplest one. Okay. So there's multiple ways you can try to do things on the calculator, but generally there are certain modes that will make certain things easier. Polar makes circles very simple. Right? On the other hand, as I said, it would make lines very complicated. Right? Lines would be very complicated in polar. Nowhere near as easy as y equals mx plus b. Okay, so what does a polar coordinate system look like? Well, first of all, a polar coordinate system doesn't use any type of x or y axis. It uses what we call a polar axis. And that's it. There's one axis when you do things in polar. Okay? Everything is measured from the polar axis. In the middle, you can still call it the origin, but a lot of times they call it the pole. That's the middle. Okay. As you start to go around the circle, there's grid lines. In this case, each grid line represents 15 degrees. So 15, 30, 45, 60, 75, 90. You can have more or less grid lines on the paper, just like regular graph paper. Sometimes they divide the grid up into tens, 10, 20, 30, 40, 50. That gives you a little bit more accuracy. Okay, but that's what polar graph paper looks like. So when we write something in polar, we don't use x and y. So now this is going to be very similar to what we did with complex numbers. When I gave you something like this, and I said to rewrite it in trig form, well, sometimes they call it polar form instead of trig form. Same thing. What were the 2 letters that we used?
R.
We used r and theta, and we did something like this. R cosine theta, I sine theta. So you had to find r and theta. What did r stand for? radius. So it was the size circle. It's basically if you were starting at the origin, how far out did you go? And then the angle is the amount of rotation to get up to that point. So those are the two things we have to figure out here, and you figure them out exactly the same way that we did earlier in the week. There's no difference. The only thing that's a little bit easier is we're not dealing with I. Okay, we're never going to have imaginaries with this. So R is movement out from the center, and theta is an amount of rotation. So the first thing I'm going to show you is how do you graph a point like that? 3, 45 degrees. That is a polar coordinate. And I'm going to ask you to plot it, and it'll be on the test as well. You'll just have to click where you should put that point. Okay. First thing you have to do to graph that is look at the R. There's two different types of R values you could have, a positive and a negative. If R is positive, you're going to start at the origin, and you're going to go to the right. How many units to the right? Well, depends on what R is. If R is negative, you're going to start at the origin, and you're going to move to the left. How many units to the left? Well, depends on, again, what R is. So in that sense, it's very similar to graphing like X, when you have an XY coordinate. If it's right, if it's positive, you go right. If it's negative, you go left. And like an XY coordinate, you're not done. Once you graph X, you still have to then use the second part of your coordinate. If it was a Y value, it would tell you up and down. This is not a Y value, it's an angle. What are the two directions that you can rotate on a circle?
Clockwise and counterclockwise.
Right, clockwise and counterclockwise. If your angle is positive, that is a counterclockwise rotation. That's exactly how we've been doing it all year. As you go in a counterclockwise direction, the angles get bigger. They get more positive. If you go in a clockwise direction, that's the direction you would go when you have a negative angle. Okay, so you do step 1 first. R is going to tell you how far out to move. And then from that point, you're going to rotate either counterclockwise or you're going to rotate clockwise. Okay, so now we'll just practice graphing a few points in polar. And then I'm going to show you how to convert a polar coordinate back to a rectangular coordinate and rectangular to polar. So we'll do the conversion each way. And then I think there's a lot of graphing. Convert to rectangular, and then convert to polar, and that's it. Yeah. But we'll practice a lot of graphs. Keep that there. I'll keep the directions up while we do the first one. Okay, so first thing, is R greater than 0 or less than 0 in example 1? Greater than 0. So starting at the origin, I'm going to go which way? To the right? How many? 3 units. Okay, I can put a temporary mark there. That's not my answer. But that's where I'm going to start now for step 2. From that X, I need to rotate. How many degrees do I need to rotate?
45 degrees.
I need to rotate 45. Which direction?
Counterclockwise.
Counterclockwise. 45 degrees is about halfway through the quadrant. So that's where you'd put your answer. So on the test, you'll have a grid, just like that in Polar, and you'll be able to click where you want to put your point. Okay. If it's a little bit off, that's fine, but I mean, if you had your point like way over here, no, that's not 45. Okay, so you got to make sure you put it on the right radius, the right circle, and the amount of rotation is also correct. If that's a decimal, you can go in between. Like if it said 3.5, I could go out in between the third and the fourth circle. So you can do decimals just like always. Let's try this one. -2, 75. Okay, so that's a negative radius, positive angle. Okay. What am I going to start out by doing? Left 2. So we're going to start from right there. And then I'm going to rotate how many degrees?
75 counterclockwise.
75 counterclockwise. Right? If I went the whole quadrant, that would be how much?
90.
Yeah, if you go from axis to axis, that's 90. So we're a little bit before. And that's how you graph -2, 75 degrees. Okay, what I would do is if I had to graph like 5 or 6 of them, I would just set up one grid, and then I would label, like if this was number 2 on the homework, I'd just say, okay, that's number 2. And then if I can put example 1 wherever example 1 was. Then you don't have to draw the same grid a lot of times. Okay, let's try this one. Positive radius, negative angle.
Right 3.
So we're going to go right 3. Start from there.
Clockwise, 60 degrees.
And we're going to go clockwise 60 degrees. Well, halfway would be how much?
45.
So we'll go a little more than halfway. So about, maybe about right there. Okay, any question on that one? All right, so we got 3, -60. Any questions on that one? Let's try this one. -4, -3 pi over 2. So yep, you can have radians just like you can have degrees. If you're not comfortable with it in radians, you could convert it. What's -3 pi over 2 in degrees?
Is this what it has?
The 270?
75.
How much is it?
Hold on.
-3 pi over 2?
I know. I can figure it out myself.
Negative 270.
-270.
Oh, do you know why you were so close?
Okay. So -4, -270. How would I get to that one?
Move left 4,
Left 4, 1, 2, 3. So I'm on the outermost circle.
and then go clockwise 270 degrees.
Clockwise 270. So where does that land me?
On the 4th axis, the bottom axis.
No, on the 90-degree axis.
Yeah, it's gonna, if you start, actually I don't want to put a point there.
No,
No, it would be on the bottom.
That's,
that's
That's
counterclockwise.
counterclockwise.
She
You're
was
supposed to
right
go
the first time.
clockwise.
It's the bottom axis.
so negative, we're going which way?
Clockwise. so-
Clockwise.
Clockwise.
Yeah.
So she was right the first time.
So you would end up right there. Okay. What's another way you could write that same point?
0, -1.
Negative 4, 90.
So -4, 90. Let's try that. So -4, 1, 2, 3, 4, and then 90 degrees that way. Yep. What's another way?
Positive.
+4, -90. So 1, 2, 3, 4,
So good. So good.
-90. What's another way?
Positive 4, 270.
Positive 4, 270. 1, 2, 3, 4, and then go 3/4 of the way around. So if you have a point that is not on the polar axis, okay, we'll see what happens on the polar axis, but if you have a point not on that axis, there are 4 different ways to get to it. You can go right clockwise, right counterclockwise, left clockwise, left counterclockwise. And that's what those 4 different ways represent. Okay. Now, if you're in rectangular, let's see. And let's say here's your axis. And I want to get to that point. What's the coordinate of that point?
3, 1.
3, 1. Is there any other coordinate you can write to get to that point?
No.
No. So in a rectangular coordinate system, there is only one coordinate, one set of numbers that will get you to that spot. In polar, there could be up to 4. Now, if you say, well, couldn't you like go right and then go around more than once? Well, if you consider that, then yeah, there's infinitely many ways. But I don't consider going around more than one time a different way. Okay. So right clockwise, left clockwise, right counter, left counter. Those are the 4 ways. So then what happens if you land like right here? Well, what's one way you could write that point?
2, 0.
So 2, 0. There's no amount of rotation clockwise or counterclockwise. So you can't say right and then clockwise and then right and then counterclockwise. There isn't. It's just right. So there's only 2 other ways you could write that one.
Negative 2, 180.
Right. You could do -2, a 180, and a -2 with a -180. There are only 3 ways to get to this one. So any point on the polar axis has 3. Anything not on it has up to 4. And the reason that's important is because when I have you convert a rectangular to a polar point, maybe when you do it, you get this as an answer. But if it's multiple choice, maybe I wrote that as an answer. You need to understand those 2 are the same thing. Okay? So you can add 360 to make something positive. We've talked about different ways you can do that. Or the easiest way is, if you're not sure, do a graph. Graph the points real quick and see if they look the same when you graph them. All right, let's try this one. 0, pi. So where's it going to be?
Origin.
It's going to be at the origin, but there's something important you need to do. Right? So it's there, but what's the amount of rotation?
180.
180. So what you want to do is that. The way I check for that is when you put your pencil down, right? I call it the rotation spin factor. You put your pencil down and you rotate. I look at the magnifying glass. And I can tell if you've rotated that amount. If it's just that, I can tell there's no swirl. You know what I mean?
Okay.
Some people are not sure. I'm just kidding. Yeah.
So if it's always a 0, it's always going to be nil. It's like it's not moving at all.
Yeah. Yeah. Because no matter how
I know you're lying.
you rotate it, it stays right where it is. Yeah. Okay, so glad we got that now.
How much zoom do you have on
A lot. If I need to, I go to science and get a microscope, and then I'm all set.
that?
500x.
Okay.
All right. How about this one? So we had 0 in the first spot, 0 in the second spot. Is that going to be at the origin?
No, go
No.
over 2.5, and then there's just no rotation.
Yeah. So we're going to be right there. So when 0 is in the second spot, that means your point is on the polar axis somewhere. But it's not at the origin. The only way it can be at the origin is if the first number is 0. Okay. Any question on graphing a polar coordinate? Okay. That's kind of the same thing. So we already pointed that out. There's more than one way to graph something in polar. If you're not on the polar axis, there's up to 4. If you are on the polar axis, up to 3. And again, we're not counting something like this going around 6 times and then stopping is a different way. It was still right and then rotating counterclockwise. All right, so last 2 things we're going to look at is changing from polar to rectangular and then the other way. Okay. When you are given a point in polar, what are the 2 components of the coordinate that they give you?
Radius and angle.
They give you a radius and they give you an angle. If you want to convert that back to the kind of coordinate system that we were using before, like parametric uses and like function uses, what are the 2 components of the coordinate in a rectangular system?
X and Y.
Right. In rectangular, we don't describe things as an amount of rotation and distance from an origin on a circle. We describe things using left and right, and up and down movement. So let's see how we can convert an r and a theta into an x and a y. Okay. So let's say we had a point in polar. Right. I don't know what the coordinate is, just generic coordinate. R theta. R measures what?
Radius.
Which is the distance from that point
To the origin.
to the origin. So this right here is R. That's my radius. What's theta?
The angle,
Angle between
0 and the point. Right.
Angle between the axis and the point.
angle between, yeah, the polar axis
Mhm.
and that point, or you really could say like the, well, this is going to be the name of a side in a triangle in a second. But it's the rotation amount between the polar axis and that point. So that's theta. Now, we want to convert those 2 things into a horizontal amount of distance and a vertical amount of distance. We want to figure out the x and the y. What trig function would we use if we want to get a formula that relates x, that given piece of information, and that given piece of information? Cosine. So cosine would equal what?
X over R.
X over r. So then what would x equal?
R cosine theta.
R cosine theta. That describes the horizontal movement of a coordinate if you know the rotation amount and the distance from the origin. It converts it into a horizontal motion. Right. Now the y is the vertical. Any guess on what the y is going to be?
R
Sine
sine
theta.
theta.
Or sine theta. Yeah. So that takes an amount of rotation and a distance from the origin and converts it into a vertical amount. If you figure out r cosine theta and you figure out r sine theta and you put a comma between them with a set of parentheses, you have now changed it into rectangular. Okay, so those are the 2 formulas you need to convert from polar to rectangular. Which trig function that we use a lot did we not use there?
Y is
Tangent.
Tangent. That's because tangent is to do the reverse. So we'll talk about that in a minute. All right, so let's convert that to rectangular. What did we just say the formula is for x?
R cosine theta.
R cosine theta. So filling in my values, what is the formula going to look like for this problem?
2 cosine theta, 200
2 cosine negative 200. And what's the y value going to look like?
You sine negative 200.
2 sine negative 200. Okay, is 200 a multiple of a 30 or a 45? No, then it's not going to come out to a nice answer. If it was going to be a multiple of 30 or 45, it would be an answer with a root 3 or a root 2 in it. A root 3 if it was a multiple of 30, and a root 2 if it had the 45. Okay, but we don't have to worry about that in this one. So 2 cosine negative 200, and before I hit enter, I need to check something.
Change it to degrees.
I am not in radians, okay? I am in degrees in this problem. So make sure your calculator is in degrees. Okay, so we got that. And we get about negative 1.80. Okay, and the y value, 2 sine negative 200. It's about 0.68. So to convert that into rectangular, it becomes negative 1.80, comma, 0.68. Okay. Any question on that? So what I did is I graphed the original point in polar. Okay. I went 2 units right, 1, 2, and then I rotated 200 degrees clockwise. Well, that's 180. And then if I went to this first line, each one of these lines is how much? 15. So if that's 180, that's 195 right there. So 200 is just a little bit past it. So is any question how I graphed that point? And everyone agrees that that is correct. Okay. So what I'm going to do now is I'm going to zoom back in. I'm going to take, and in place of that polar grid, I'm going to leave that point right where it is, and I'm going to drop a rectangular grid behind it. This rectangular grid is exactly the same size scale as this one. Like if you look at the distance between 2 of them, right there, I'll just draw it to show you. That's the distance between 2 circles. Well, it's also exactly the distance between 2 lines. So they're the same scale. That's what I'm trying to show. So if I drop in a piece of graph paper with a set of axes on it, this point should look like it's at exactly negative 1.88 and then up 0.68. All right, let's try it. Does that look like it's almost 2 units left and a little bit more than half a unit up? Huh? Yeah? That's pretty good, huh? So there it is in polar. And then it's like, now it's in rectangular. I wait all year to do that. Pretty neat.
Who is this new person here today? Who are you?
So
He's excited.
So that's how you can kind of check it. You can't obviously do that on paper. But if you had a computer, you just drop in a different background behind it, and you can see it lands exactly at the right spot. All right, let's try one more. So let's convert that to rectangular. What's my x formula?
3 cosine 5 pi over 6.
3 cosine 5 pi over 6. And the y formula?
3 sine 5 pi over 6. That was the first thing I
Okay.
wanted.
Now, pi over 6 is how much?
Isn't that
30?
30. So this is definitely a multiple of 30. It's 30 times 5. That means we are going to get an answer we should recognize. So we can change back to radians, that's fine. don't multiply by 3 yet. Just do cosine 5 pi over 6. That is a special number, negative 0.866.
Oh,
What number is 0.866? And we have to put a negative in front of that.
3 pi. 15, 30, 45.
It's in the 30, 60, 90 right triangle on the unit circle. Has a square root in it.
Oh, screw.
It's not root 2 over 2, because that would have to do if this was a 45.
So it's 1/2 root 3 over 2.
Yeah, it's one of those numbers.
Root 3 over 2.
That is root 3 over 2.
Root 3 over 2.
Okay, you need to put a negative in front of it, but
This is 5.
cosine of 5 pi over 6 is negative root 3 over 2. I did not multiply by the 3. If you multiply by the 3 at the same time, you are going to get confused, because you're going to see this number, and you're probably not going to recognize negative 2.59. So that's why I do not multiply by the 3 first. I'll multiply by the 3 last. That's my x value. Negative 3 root 3 over 2. Right? And then when one of them comes out with a root, the other one usually comes out very nice. So sine 5 pi over 6, that is 0.5. So 3 times 0.5, 1.5. Right? So writing your final answer in rectangular, it's negative 3 root 3 over 2. That's a 2. Comma 1.5.
If you know that's an equation in radians, is it okay if we switch it to degrees or will we lose points?
Yeah, you could change it to degrees,
Okay.
as long as you end up with that as the final answer. Yeah. Yep. So the only time you're going to be looking for a square root in the answer is if this angle is a multiple of 30 or
15. No.
45.
45. Yeah.
15.
Not exactly.
Okay. So any questions on converting to rectangular? Right. Now, last thing
I'll take your word.
is the other way, polar, converting it back. Okay. In rectangular, what are the 2 pieces of your coordinate?
Excellent.
X and Y. In polar, you don't want X and Y. Now we want X and Y to disappear. We want to turn that into an R and a theta. Okay, so I've got the same kind of diagram again. These 2 pieces of information will be given.
And
R will not be given. If you know X and you know Y, how are you going to figure out your distance to that edge of the circle?
Pythagorean theorem.
So this is what we did when we did the complex numbers. Pythagorean theorem will give you R. And now, how are you going to get your angle?
tangent.
Great. You're going to do the tangent equals y over x. But now, how do you get rid of tangent?
Inverse tangent.
Yeah. So theta is the inverse tangent of y over x. But that's only going to work in certain quadrants. It's the same quadrant it works in when we talked about complex numbers. Inverse tangent y over x works in what quadrants? Yeah.
Quadrant 1 and quadrant 4.
Quadrant 1 and quadrant 4. What if you want to get an answer in 2 or 3? What do you have to do to that? Add 180. Yep. Okay. So the first thing you need is you have to know your quadrant, because the formula depends a little bit on the quadrant. If you are in quadrants 1 or 4, you can use the inverse tangent of y over x. if you're in quadrants 2 or 3, you can still use inverse tangent y over x, but you have to add 180. Okay, that's exactly the same formula as you had on Monday, when we converted complex numbers to trig 1. Now, what if you're not in quadrants 1, 2, 3, or 4?
You would be on one of the axes.
And what are the angles on the axes?
0, 90, 180, and 270.
Right. So if you're not in a quadrant, you're on an axis, you have to memorize those 4 answers. The reason you can't use the formula, what's the coordinate for that point right there?
0, 1.
Well, it's 0
Or
something. We don't know how high it is, but it's 0.
Yeah.
And if x is 0 and you try to fill it in,
And defined.
you'd be dividing by 0. So these formulas don't work if you're on an axis. Okay, so that's how you find your angle. And how did we say you find your radius?
Pythagorean theorem.
Yeah. R squared equals x squared plus y squared. Okay, so let's try an example where we convert from rectangular to polar. I got 2 of them. Well, that one's easier because it's on an axis, so let's do the one that's harder. 3, -5. Okay. What letter is the 3?
R.
X.
That's x. Right? You don't have polar. You're trying to get polar. So they're giving you an x and a y. Let's do the r first. What's my formula to find r?
Theorem.
Pythagorean theorem. And how would you set it up?
R squared equals x squared plus y squared.
R squared equals, what's x squared?
3 squared is 9.
And y squared?
25.
So r squared is
Oh, wait. 34.
34.
But then it would take the square root. So r would equal the square root of 34.
Yep. And let's see, 4 times 9 is 36. So there's no perfect squares that go into that. So that's as reduced as you're going to get. Okay, so there's my radius. Okay. What quadrant is 3, -5 in?
2.
Right 3, down 5. Right there. So what quadrant is that?
4.
4. What's the formula to find theta in quadrant 4?
Theta equals inverse tangent y over x.
Inverse tangent y over x. Okay, so now we just type it in. It's not going to be a nice answer, so I would just do it in, I would have done it in degrees. We can still change it, we haven't hit enter yet. So that's an angle of -59.04. Okay, so now, how do I write my final answer in polar?
Square root 34. And then -59.04.
0.04. There you go. That's your answer when you convert from rectangular to polar. Any question on that? Okay. So that's the homework. I will put the list of test topics on the board probably while you're at lunch.